Namaste children. Today we will continue the lesson real numbers exercise 8.3. Exercise 8.3. Dear students, in exercise 8.3 the first main is completed. Now we go to the second main. Prove that second main. Prove that 3 plus 2 root 5 is irrational. So, proof. Let us assume to the contrary that 3 plus root 5 is rational. That 3 plus 2 root 5 is rational. So, assume now assume let us assume to the contrary that 3 plus root 5 is rational. This implies that 3 plus root 5 is equal to P and Q. So, P and Q are two positive integers. P comma Q belongs to Z, where Q is not equal to 0 and P comma Q is equal to 1. So, there is no other common factor for P and Q other than 1. 1 ಅನ್ನು ಹೊರತುಪಡಿಸಿ P ಮತ್ತು Q ಗೆ ಯಾವುದೇ common factors ಇರೋದಿಲ್ಲ. There is no other common factors of P and Q other than 1. So, 2 root 5 is equal to P by Q, here 3 minus 3. So, root 5 is equal to P by Q minus root 5 is equal to P by 2Q minus 3 by 2. So, this implies that root 5 is equal to, we take LCM 2Q get cancelled, the remaining number is P minus 2 cancelled, 3 into Q is equal to 3Q. So, root 5 is equal to P minus 3Q by 2Q. So, here P minus 3Q by 2Q is a what? Is rational number. Is a rational number. But root 5 is an irrational number. This is not possible. Once again, let us assume to the contrary that 3 plus root 5 is rational. 3 plus root 5 is equal to P by Q, where P comma Q belongs to Z, q is not equal to 0 and p comma q is equal to 1. 2 root 5 is equal to p by q minus 3. So root 5 is equal to p minus 3q by 2q. So here p minus 3q by 2q is a rational number, but root 5 is an irrational number. So this is not possible. Our assumption is wrong. So 3 plus root 5 is an irrational number. Therefore our assumption is wrong. Therefore our assumption is wrong. So 3 plus 2 root 5 is irrational. Therefore our assumption is wrong. So 3 plus 2 root 5 is irrational. So dear students, we go to the third line. Prove that the following are irrational. Third line. Prove that the following are irrationals. Following are irrationals. First one is 1 by root 2. Proof. Let us assume to the contrary that 1 by root 2 is rational. Now ಏನು ಮಾಡ್ಕೋಬೇಕು ಫಸ್ಟ್ 1 by root 2 ನ rational ಆಗಿ assume ಮಾಡ್ಕೋಬೇಕು. Let us assume to the contrary that 1 by root 2 is rational. Let 1 by root 2 now 1 by root 2 is equal to p by q, where p comma q belongs to z, where q is not equal to 0 and p comma q is equal to 1. So there is no other common factors of p and q other than 1. So take root 2 on both sides. Take root 2 on both sides, numerator and denominator. Take, multiply the root 2 on both sides. Multiply root 2 on both sides. We get 1 by root 2 into root 2 by root 2 is equal to p by q. So this implies that root 2 ones are root 2 divided by root 2 into root 2 is what? Root 2 into root 2 is 2. Here 2 root 2 into root 2 is equal to 2 root whole square. here 2 and square root get cancelled. Square root cancel. The remaining number is 2. So root 2 into root 2 is equal to root 2 whole square. Square root cancel. The remaining number is 2. So root 2 into root 2 means 2 is equal to P by Q. Next we take cross multiplication. Therefore root 2 is equal to 2P by Q. Root 2 is equal to 2P by Q. Okay students, here 2P by Q is a rational number and root 2 is an irrational number. This is not possible. Our assumption is wrong. Therefore 1 by root 2 is an irrational number. Here here 2 by Q is a rational number, but root 2 is an irrational number. This is not possible. This is not possible. Therefore our assumption is wrong. So 1 by root 2 is an irrational number. Once again, 2P by Q is rational number, but root 2 is irrational number. This is not possible. Our assumption is wrong. Therefore 1 by root 2 is an irrational number. Second problem, 7 root 5. Second problem, 7 root 5. Prove let us assume to the contrary that 7 by root 5 is rational. So let us assume to the contrary that 7 root 5 is rational. So 7 root 5 is equal to P by Q, where P comma Q belongs to Z, where Q is not equal to 0, P comma Q is equal to 1. There is no other common factors of P and Q other than 1. So root 5 is equal to P by 7Q. Here root 5 is equal to P. Then ಅಂಶದಲ್ಲಿರುತ್ತೆ 7. ಕೆಳಗೆ ಬಂದು is equal to ಈ ಕಡೆ ಬಂದು ಏನಾಗುತ್ತೆ ಛೇದಕ್ಕೆ ಬರುತ್ತೆ. Numerator and we go to the denominator. P by 7Q. Here P by 7Q is a is a rational number, but root 7. Once again, I made a mistake. This gives, so SS, root 5 is correct. Root 5 is equal to p by 7 cube. P by 7 cube is a rational number, but root 5 is an irrational number. This is not possible. Therefore, our assumption is wrong. Therefore, our assumption is wrong. So 7 by root 5 is an irrational number. Irrational number. So once again, proof. Let us assume to the contrary that 7 root 5 is rational. 7 root 5 is equal to p by q. P comma q belongs to z. Q is not equal to 0. P comma q is equal to 1. This implies that root 5 is equal to p by 7 cube. Here p by 7 cube is a rational number, but root 5 is an irrational number. This is not possible. So our assumption is wrong. So 7 root 5 is an irrational number. So in third line, first and second problem is completed. Now we go to the third problem. 6 plus root 2. 6 plus root 2. Let us assume that so 6 plus root 2. Let us assume to the contrary that 6 plus root 2 is rational. Let us assume to the contrary. Let us assume to the contrary that 6 plus root 2 is rational. Is what? Is rational. So 6 plus root 2 is equal to p by q, where p comma q belongs to z, where q is now equal to 0 and p comma q is equal to 1. So this implies that root 2 is equal to p by q minus 6. Take LCM. Root 2 is equal to, take LCM, q cancel, the remaining number is p. So 1 q is q into 6 q. So here p minus 6q by q is a rational number. Is a rational number, but yes, Root 2 is an irrational number. Irrational number. Irrational number. This is not possible. This is not possible. This is not possible. Therefore, our assumption is wrong. So 6 plus root 2 is an irrational number. Is an irrational number. Once again, 6 plus root 2. Assume that 6 plus root 2 is rational. 6 plus root 2 is equal to p by q, where p comma q belongs to z, comma q is not equal to 0, and p comma q is equal to 1. Root 2 is equal to p by q minus 6. We take LCM. Root 2 is equal to q cancel. The remaining number is p minus q ones are q into 6, 6q. Here, p minus 6q is a rational number, but root 2 is an irrational number. So, this is not possible. Therefore, our assumption is wrong. So, 6 plus root 2 is an irrational number. Last problem. Prove that root 3, yes, root 3 is irrational. Root 3 is irrational. Proof. Let us assume to the contrary that root 3 is rational. Root 3 is rational. Now, root 3 is equal to p by q, where p comma q belongs to equal to 0 and p comma q is equal to 1. So, root 3 is equal to, so there is no other common factors. There is no other common factors of p and q other than 1. So, once again, now this implies that p is equal to p by q. Here, this implies that root 3q is equal to p. Once again, this implies that root 3 is equal to p by q. Root 3q is equal to p. Squaring on both sides. We get root 3q whole square is equal to p square. So, square and root get cancelled. The remaining number is 3. Q q into q square, q into q square is equal to p square. This implies that 3 divides p square. This must be equation 1. 3 divides p square, then 3 also divides p by theorem. Once again, square, root and square get cancelled. The remaining number is 3. Q square is equal to p square. Equation 1. 3 divides p square. Then 3 also divides p by theorem 8.3. Now let p is equal to 3m. What? P is equal to 3m. We take p is equal to 3m and substitute p value in equation 1. So here equation 3q square is equal to p square. Here 3q square is equal to p square means 3m whole square. 3q square is equal to 3 3s are 9. 9 can be right. 3 into 3, m into m square. 3 get cancelled. Q square is equal to 3 m square. So q square is equal to what? 3 m square. Therefore Therefore, 3 divides q square. Then this implies that 3 also divides q by theorem. So, therefore, 3 is the common factor for both p and q. So, 3 is the common factor for both p and q. So, therefore, 3 is the common factor for both p and q. Therefore, this is not possible. Our assumption is wrong. Therefore, root 3 is an irrational number. Once again, our assumption is wrong. So, 3 is the common factor for both p and q. Therefore, this contradicts that there is no common factor of p and q. Therefore, our assumption is wrong. Therefore, our assumption is wrong. Root 3 is irrational. Once again, let P is equal to 3m. Substitute P value in equation 1. 3q square is equal to P square. 3q square is equal to 3 into 3m square. 3 get cancelled. Q square is equal to 3m square. 3 divides q. Then 3 divides q square and 3 divides q by theorem 8.3. Therefore, 3 is the common factor for both P and Q. This contradicts that there is no common factor of P and Q. So, our assumption is wrong. So, root 3 is irrational. Dear students, the chapter is completed and do remaining all the worked examples and exercise problems yourself. Thank you.